Virtual machines. Welcome, guys. In this video, we'll be talking about in-depth explanation on virtual machines and virtualization technology. So, what are virtual machines? Virtual machines are a virtual version of your physical machines. Like when you have a similar in a linear time, it's like a computer inside your computer, and there are a lot of reasons why you might want to have another computer inside of your physical computer. So we're talking about all of that in this video. Just understand when they say virtual machine, it's just another computer on top, or that you can run, that you can use inside your physical computer, and you can have as many as possible more computers inside your computer. That is, you can have as many as possible virtual machines in your physical computer. All right, now let's talk about life before virtual machine, and this will let you understand the reason why VMs are created in the first place. So, life before virtual machines, to run app and services or on servers or whatever the case may be, you need to get a lot of physical machines. Let's assume that you want to run a web service, or you have a website, and then you want this to be very reliable to some extent. You will want to create you want to buy a machine that will use database, another that will some other service, maybe file of the machine, and you have another machine that will serve as that will produce that present the content, the HTML, CSS to the users. So all of this will require its own all of these services will require their own machine, computer in another term. So all of these services will require their own computer, and if it were to be in a large scale, they will use servers. So all of these services require their own servers, and even if you are not talking about a app, web app, or a website, in organizations, enterprises that they have a lot of users, and organization will have applications as well that they use. So instead of doing this, they will have to purchase servers for each of the services that they use, be the domain service, web service, data service, everything. They have to purchase service. That's how it works, life before virtual machines. So all these systems require a physical machine, and then to have higher reliability of these servers, you have to provide one service for one server. So all of these services will be running in isolation, so it will be one service for one server, and then just they always over provision these servers. So servers are always over provision in the sense that you have more resources for a service. For example, if you are running a service, maybe a database service that requires maybe 50 gig of size, so you'll have to provide you'll have to provide a server that will run like maybe 200 gigabytes. That's how they do it. They always over provision servers. So, and then when this happen, all these server resources will be underutilized, because that's their goal. They don't want these servers to be overutilized, so as to ensure that they run adequately. So, and this will be leaving out a lot of resources unused, and this leads to huge capital expenditure and oftentimes operation expenditures. Capital expenditure simply means capitals used to purchase all of these servers, the networking to set them up, everything. It requires a lot of money. And operation expenditure as well, people or manpower that will manage these resources will have to purchase is like people that are qualified to manage these resources, because managing resources, you can't just put any technical person into there to like manage the resources for you. You have to use people with regular certificate, and this will require more money because you have to pay them what they are worth. So all of this, it takes a lot of money, a lot of resources and energy. So that's what happened. Like, that's the life before virtual machines. So now we enter the world of virtualization. And then maybe you should understand virtualization simply means just virtualization. This is this, will I say, the service, yes, that enables enables a physical machine to be able to create virtual machine. So it works by dividing the resources of your physical machine. So in subsequent video, we're talking about how to create one. So during the creation of a virtual machine, you will have to provide the RAM size, the hard disk size, and some other physical resources. You have to allocate that to your virtual machine. So it's the work of the virtualization to divide the resources of a physical machine and give some of it to your virtual machine. So that's what virtualization does. This is what enables um, virtual machine creation. And one of the common tool virtualization tool is VirtualBox. So sorry, sorry, there's a mistake there. All right. So VirtualBox is an hypervisor. Sorry, hypervisor is what enables virtualization. Sorry, it is what divides the physical machines resources. So virtualization is simply the creation of VMs. So what enables this creation is hypervisor. And in previous slide, I talked about live before virtual machine. So in this case, let's talk about what now happens. What are the solutions that virtualization brings to us? So virtualization, like I said, enables us to run multiple operating systems on a physical machine. In a later, it allows us to have more than one servers on a physical machine. The isolation that we so crave before before virtual machine, virtualization enables us to have that isolation. So we'll be able to partition physical resources into virtual resources. And virtual machines run in isolated environment. Like I said, multiple OS virtualization enables us to create um, multiple OS, to run multiple OS on a physical machine. So each virtual machine needs its own operating system, different operating system. So and server virtualization is the most common virtualization because that's the purpose of creating virtual machine, just to solve this capital expenditure and operation expenditure of physical servers. So that's why virtualization comes in, and this helps a lot. Just imagine having a data center that has like 20 servers, and then we have to get a lot of like people required staff that will be able to manage this, and this will consume a lot of power. You need to provide power supply, networking, and all those services, all those resources will be needed, and that will take a lot of money. So in virtualization, maybe I might have one or two servers that will serve all this, the purpose of all these physical 10 physical servers. We just need to provide that we're able to run hypervisor on, and once hypervisor is running on, then you can run as many as possible virtual machines on all of those. So it's just so simple, guys. So virtual machines live before it is so difficult. People spend a lot of money, a lot of resources and energy to maintain these servers and ensure that they are running adequately, and the resources on these servers are always over provisioned because you don't want the servers to break down. You have to over provision them. So to talk about virtual machines and talk about live before virtual machines, and importantly, live before virtual machine is so important. So then we run one service per server, and physical servers are just located in data centers, and to maintain data center, you need to have a lot of resources, both monetary resources and intellectual resources. So there is a lot of huge capital expenditure and operation expenditure. Right. So these are some of the terminologies you should be aware of in the virtual machine world, so to speak, or virtualization world. So host operating system. Host operating system is simply the operating system of your physical machine. That is the machine that is hosting this virtual machine. So that's the host operating system. The guest operating system, this is the operating system of the virtual machine, and VM stands for virtual machine. Then we have snapshot. Snapshot is just a backup of the virtual machine. Snapshot means backup of the virtual machine. And hypervisor, this is the two software that helps us create virtual machine. This is what enables virtualization on your physical machine. And oftentimes you need to be aware of this. That's why it is in this video, because when you are talking to peers or other engineers, maybe in forums or in groups or online, anywhere online, they, especially among engineers, they use these terms a lot. So for you not to get lost, you need to understand host OS is the operating system of the host, so the physical machine. Then the guest OS is the operating system of the virtual machine. VM stands for virtual machine. Snapshot is just a backup of the actual virtual machine, and hypervisor, this is what enables virtualization, so makes virtual machine possible on your physical machine. All right, now let's talk about hypervisors a little bit. I think formally talk about it a little while. So basically there are two types of hypervisor, and like I said, this is what enables virtualization so on physical machine. So type 1 hypervisor is also called bare metal. If you can remember, when I talk about servers, so this bare metal hypervisor, this is the hypervisors that are used on production servers. So they don't require a host operating system to run on the physical machine. So they just run it on the, your host operating system. For example, I'm using a Windows machine, and on top of the Windows machine I can install a Linux virtual machine. So the Windows machine on my physical machine is not required in type 1 hypervisor, so you just install it as the OS of the machine. So on top of it, then you can start installing the guest operating system. So this type 1 hypervisors, they call bare metal, and they run as the basic operating system on the physical machine. So these are important, guys. And they are only used in production environment. And the good example of this is VMware ES11 and Zen hypervisor, that is XEN Zen hypervisor. So this operating system, as in this hypervisor, doesn't require a host operating system in a nutshell, and they are very strong compared to type 2 hypervisor. So type 2 hypervisor run as a software on your physical machine, so they run on top of an operating system. So, and they are often used for learning. They are often used for learning purposes, and a good example of that is Oracle VirtualBox. So let me show an example. This is an example of one. We have Oracle VirtualBox. So talk about that later, but this is a good example of one Oracle VirtualBox. As you can see, I have one machine running now. This is CentOS machine, and it is a Red Hat operating system. It's a Linux. So this is Oracle VirtualBox, and there are some other ones called VMware Server. I think that's from Microsoft. So these are type 2 hypervisors, and they run as a software. As you can see, it's a software on my physical machine. So I install it just like you install other softwares. If you go online, you can even search for it. Is an example virtual got the VirtualBox. Things you can download it from virtualbox.org. Yeah, this is it. Can download from virtualbox.org. Another one that is common example of type 2 hypervisor is VMware server. VMware server. So this is it. VMware server. This is it here. So it's a type 2 hypervisor. It's a virtualization software server, so developed and supplied by VMware. So this is it. So, and then talk about type 1. Let me show you an example of type 1. Talk about Zen hypervisor. Zen, yeah. So type 1 hypervisor, and it's run on the server, on the physical server. So this is it. This is a type 1 as you can see. It's even here. Zen is a type 1 hypervisor providing services that allow multiple computer operating systems to execute on the same computer hardware concurrently. So that's just little explanation of it. So this used in development, in production environment. So all of these things are free to download most cases. So can just think this is download. So it's as simple as that, guys. So we talk about so now how does this type 1 and type 2 hypervisor work? Like I explained, type 1 runs on the hardware itself, doesn't require any physical machine. So on top of the type 1, that's where you have multiple operating systems to execute on top of that concurrently. So, and in this operating system, then you can go ahead and install your own applications on top of that. So let's go over an image so that you see it. Just type 1 hypervisor. So let me show you some images that will explain it better. Oh, this is a nice example of the image. As you can see, we have type 1 hypervisor and we have the hardware. This is the RAM, this is the hard disk, physical hard disk, physical RAM, and everything. So, and on top of that, you have an hypervisor. So on top of this hypervisor, you can have different operating system, different virtual machines. All these guests that you can see are VMs. So you can have a lot of the VMs on top of that. But type 2 hypervisor, you will need, it runs on the host operating system. As you can see, in my case, I'm having Windows operating system. So on top of Windows operating system, then I install this type 2 hypervisor. Then on top of the type 2 hypervisor, then I can have as many as possible as many as possible VMs. So that's what is happening here. I installed this, which is type 2 hypervisor, on top of my machine, and within it I can have as many as possible virtual machines. This is one of them. I just finished the installation of this now. So now I can just just need to, let me create a new user here. It's just simple. Just I just call this user YouTube. Username is YouTube. We are not making it admin. You can just give it a password. So and then just go back to done at the top here. So now we have a user, the root user. Oftentimes I don't think you really need to give it a password, but let me give it in this case. So now let's finish these settings, and all right, this is an installation of a VM. In this case, it's an 12.7 VM. It's very simple. So far you have the necessary hypervisors. So yeah, Now, from the types of hypervisors, now let's talk about Vagrant. So now that you understand VMs, you understand how they are made, you understand the hypervisor and things like that. The next thing you have to understand if you want to go deep on the topic of VMs is how can you automate the creation of VMs. So this is necessary, and I will have to set it. I will have to show you some example from. Oh, sorry. I'll have to show you some example from my Oracle VirtualBox here. I told you that I created these VMs, and by the way, it's still the process is still running. The creation is not yet completed. However, the VMs are already running. I need to create some users and do some finishing on the creation. So let's say I have to install 10-20 VMs on this hypervisor. So is it must for me to creating each one of them one after the other? And you might think that we have been able to solve a lot of manual work by using VMs, not using the old servers, but we still want this work to be more simpler. So we want to be able to automate the creation of VMs. Like, how easy will it be if I can just pass some code to this VirtualBox, and it's going to create like all of these VMs for me automatically without my intervention. I just need to give it the code and it's going to create the VMs. So that is where Vagrant comes in. Vagrant is virtual machine automation tool. So we use it to automate the creation of VMs. You can use it to allocate the RAM, the hard disk size, the IP address, every other thing you can use. You can configure that settings on VMs, and you can configure as many as possible. You can use it to configure as many as possible VMs automatically. So we can it's a form of infrastructure as code. So Vagrant will create VMs for us automatically, and let me show you how it looks like. So we can have just Vagrant. So this is Vagrant, this is the logo. Let me show you the doc. So this is the main website. Alright, this is Vagrant. So this not talking. Let's go to the doc and you see some of the stuff I'm explaining. So this is the overview, fine, but we need more stuff. So it's not really talking about what it is here, but I think the doc is mainly for those that have some understanding of it. So I think you can get a little definition here. Vagrant is an open source software product for building and maintaining portable virtual development environment. Can you see that? For building and maintaining portable, in that case, fine, virtual development areas or VMs. So use it for VirtualBox. As you can see, I have VirtualBox installed already. So that's one of the requirements. So Docker containers, VMware, most of these are just type 2 hypervisors. Tends to simplify the software configuration of virtualization in order to increase development productivity. So that is the main word here, guys. So use it to simplify the creation of VMs, automate everything regarding a VM. So instead of you setting up VMs manually, then you can get into the work of Vagrant and it's going to do that for you. It's very important, guys. So what are the benefits of Vagrant? When you're creating, let me walk you through the basic process of setting up a VM on VirtualBox. So when you want to create a VM on VirtualBox, you just need to create new, give the name of the VM, give the type, and give the operating system version. This is the operating system type, then operating system version. You give that, and you click next. At the end of the day, you have to install the disk image, the ISO image of the operating system you've selected. So you download that probably from on the internet, or if you have the disk, then you you run it, because this setting says like you configuring a hardware, then you have to provide operating system of it. The ISO is the operating system of the machine. So all of this, imagine having 20 virtual machines that I want to create, so I'll have to go through all of this manually. So that can take sometimes, guys. So that can take some time. So that's one way, one of the solutions, one of the things that Vagrant enables us to like solve. So it doesn't require operating system installation. So that's what is I've been doing here for some. Okay, I think it's time for me to reboot. So now I think the installation is done, so it's rebooting. All right, so Vagrant on the other hand doesn't require OS installation. There are some ready-made operating system called box images. That's what you need, and that's what we provide the operating system. You don't need to install the operating system manually, and you are able to manage your VMs from a file, just a simple Ruby file. It's very simple to understand. You don't need to understand Ruby language. So virtual machines, you can just make changes automatically through the Vagrant file. You can easy the commands. Vagrant commands are so simple to understand, and importantly, you can even provision these VMs. Provision is the sense that maybe you intend to create a VM that will be running a web service, so you don't need to create a VM before you start provisioning it with the service. Just from the creation of the VM, you can provision it with the web service that you want to, or you intend to be using the VMs for, using Vagrant. This makes Vagrant to be very powerful, guys. This makes Vagrant to be very powerful. So anything you can do on a physical machine, so you can do it on anything you can do on a physical, on a VM, you can do it on. You can use VM, you can use Vagrant to do it. So it's as simple as that. Let's see this image, maybe it's going to help. All right, it's just as simple as this. This is a nice image. So I think this is another image. So one, you are a developer, I use Vagrant to create VMs. So the Vagrant will communicate with your VirtualBox, because okay, let me talk about the requirement of Vagrant. I think it's part of the slide. We can get into this later on. Maybe we'll come back to this so that I understand it more. And then let's see the slide, talk about benefits. So how to set up Vagrant. So we don't have the requirement. Let's talk about the requirement, then from there talk about the setting up of how to set up Vagrant. So the requirement of Vagrant, Vagrant require an hypervisor. In this example, they are using VirtualBox, and that's what I'm using as well. So it requires an hypervisor. That's the first thing. Second, an important thing is that it requires let's look at the screen. Second thing is that it requires its own application as well, because so it requires, you need to download this application. It's very simple to download, just install it like normal stuff, normal applications. So that's the second thing. And the third thing that Vagrant requires is you need to enable virtualization technology in your BIOS. So you need to enable VT in the BIOS. So this is what they call virtualization technologies in your BIOS settings. You need to enable this virtualization technology, and I know that BIOS settings are different in a lot of machines. So you just need to identify where it is located in your own physical machines and BIOS, and you have to enable it. So it's very important. So in fact, using any hypervisor, in that case you are going to need virtualization technology, so you need to enable it. This is what we share your physical machines, because that's the third thing that Vagrant requires. And then the fourth thing that I think is important is a terminal, because Vagrant is a command line tool. So you can't, it's not just like, it's not like VirtualBox that I just click around. So use command to use it, use command to control it. So you need a terminal. You can use your command prompt. You can use command prompt something. You can use something like this to control it. However, I use something called git bash. So we can let's search for that too. So git bash is so this is an example of git bash. So this git bash, this is the logo here. This is my, as you can see, is command line. So this is an example of a code on git bash. So it's very simple, guys, and it's a little bit advanced compared to the local command prompt that you have. So so don't know what's wrong with this. All right. Don't know why some of the commands are not running here. All right, but that's one of the problems of this. However, that's not the issue here. The concern here is that you need something like a terminal. In this case, talking about this. So this is very simple and easy to use a terminal. So we need that. That's one of the requirements of Vagrant. So once you have that, then we can start talking about all of this. So what this is telling you is that as you, the user, in this case developer, you have installed Vagrant and you have provided all of this requirement that I talk about. So the next thing you have to do is to get a Vagrant box image, download this, then come to find boxes. So you need to get a box image. In this case, let's say you want to install this Ubuntu. So you get this is the path to this Ubuntu box. Then from there you use a Vagrant in it before you even come to Vagrant up. So that we initialize this Vagrant file in a directory with the command of Vagrant in it to initiate this Vagrant file, and a Vagrant file is going to put this box image there. So once you have the box image, then you can run Vagrant up. Then Vagrant up will communicate with your VirtualBox and then provision your virtual machine. So after the provisioning, then the provisioning, you can set up some other things. That's what this fourth step is doing. So the fifth will get you this. So when you get this, you can use Vagrant SSH to sign into the machine, just like you telnet or to your remote machines. It's as simple as that. Vagrant, you need to create the Vagrant file, is very important. Then Vagrant up will bring up the machine on VirtualBox, just like you are seeing it here. That's how you are going to see one. So and then see system has been created. All right. So that's not that's just by the way. So Vagrant SSH to sign. Let's look for another image that we can talk about it from there. So user plus your system plus Vagrant, you can create virtual machines here. So the Vagrant machine will get box image from online repository, upload and create. So that's just basically talking about the same thing here, guys. So developer machine, Vagrant file, provision, get it some VMs. So it's still the same thing, because this public Vagrant box that I'm talking about means this is the Vagrant cloud. You get the box name and use it to provision your Vagrant. So it's as simple as that. That's how Vagrant works. So it's a simple way to understand Vagrant. All right. Let's go into the next slide. So now how to set up Vagrant. I think we have talked about that as well. So next thing is to some of the commands of Vagrant. That's what we need to talk about now. Now that you understand Vagrant and what it is and why, benefit of it. Now let's talk about the common Vagrant commands. In one of the online research that we did now, so I think from here you see Vagrant up. So Vagrant up, this is a command just like you pressing the power button on your physical machine. That's what Vagrant up does. But before you can press power up, like because you can before you can press the power button on your physical machine, and for it to come up in the way you intended, before you can do that, you must have the RAM, all the physical resources, and the operating system. So all of that should have been in place before you can power it on. So the command that will provide all the hardware, the virtual hardware and the virtual operating system is Vagrant init. And what Vagrant init basically does, it will create a Vagrant file for you. And this explanation that I'm making is valid so far you are creating just one virtual machine. If you are creating more than one virtual machine, then you have to provide your own Vagrant file, and it's very simple. You just need to create a file with this particular name, and you are going to get some let's go to the documentation. So let's see if we can so if you are creating more than one VMs, then you have to do something. You'll have to generate your own image name and IP size and things like that, which you can always get from Vagrant. So that's not so difficult to get. So this that's this the command Vagrant init. This is the command used to generate a Vagrant file. So this is the command that will provide this file for you automatically, and it will only provide the file for one machine. So if you want to create like tens or 2-3 machines at a time, then you don't need this command. What you just need is to create a file, Vagrant file, and within that I'm going to show you how to set that up. But that's just the first thing, and I will just advise that you start with creating just one VM with Vagrant. So to create one VM, just use Vagrant init, then the box name that I show you how to get. It's an example of a box name. This, put that there. So Vagrant init the box name. Then once that is done, then you run. This can take like 2-3 minutes, or let's say a minute or so, depending on the speed of your internet. All right, so once this is done, then you run Vagrant up. What Vagrant up, like I said, is just like you pressing the power button on your physical machine. Then it's going to bring up the machine. What it's going to do is that it's going to download this image, the box image you provided. It's going to download it and install it on VirtualBox. You don't need to do anything to do the installation, and it's going to boot it up. Can you see? It's going to install and boot it up. So what you just need just to sign in and start using the VM. So Vagrant SSH is used to sign in. So use Vagrant SSH and it's going to sign you. As you can see, this user has signed into this VM. So these are the 3 basic commands, and then let me show you some other. If you want to a scenario where you want to create more than one VMs at a time. So from after that, we can talk about more virtual and vagrant commands. Okay, so now we are need to go to the docs. So I'll show you that. So now if you come to the docs here, you see multi-machine here. So multi-machine, if you read all of this, what is basically telling you is that multi-machines are defined within the same vagrant file. So it means what most of the things here is only telling you that you have to create your own file. Then in that file, you will have to provide these defining multiple machines. This command, you have to provide this command, and this is not just a command out there, you can add to it. So what this command is saying is that you have this main configuration, like the global configuration, or let's start from the middle. We have a configuration for each machine. This machine 1, machine 2. That's within this set of config VM define. Within that, you have particular instructions for the machine. So this particular machine, this instruction goes for this machine. So this instruction goes for this machine, and the instruction outside of these two is within the global config, which goes for both machines, or whatever the amount of machines we have within this global config as. So all this instruction will run in these machines when they are up. In a nutshell, to have more than one machines, you have to get these config files, as many as possible, as many as the amount of machines you want, and then this is used to provide the box image. As you can see here, this is the box image, and from there you can provide the IP address, you can provide the RAM size, you can even provision it. So you can even provision it. This is the provision section. All you just need just to copy this and put it just below this, above this end line. Provisioning will work, or if you want it to have work for just one of the machines, you can put it above this end line here, above this end line, depending on the machine you want it to work for. All right, so it's just simple, guys. And something else you need to understand is that now, when you want to bring up just one machine, you just use vagrant up. So in the case where you have created a vagrant file of multiple machines, vagrant up will bring up all the machines, and that might not be the case, or that might not be what you want to be doing always. So let's say in this case where you have two machines here, we have the first one is first web, and the second one is DB. So what they are saying here is that if you want to bring up just one of them, all you have to do is provide the name. For example, vagrant up, the name, not just vagrant up. So you need to provide the name of the machine, so you to bring up just that one machine. And that's just the basics of setting up multiple machines. And now let's talk about some other important commands that you need to know. Is to shut down a vagrant machine. If you use after vagrant SSH to sign into a machine as well, use vagrant SSH, then the machine name, maybe web or DB, as per the this case that I'll talk about here. So if other commands that other vagrant commands is vagrant alt. She's used to shut down a machine, and in the case of having more than one machine, it will be vagrant up, then the machine name be vagrant up web or vagrant up DB. All right, so that's vagrant alt to shut down. Another command that I think might be useful is vagrant destroy. That's used to delete. In fact, it's going to delete it from the hypervisor. In this case, whatever VMs you have running is going to delete your VM. That's vagrant destroy. And vagrant reload is used to reboot a VM. It's used to reboot a virtual machine. And I think that's basically the commands we have for vagrant init, vagrant up, vagrant SSH, vagrant alt, vagrant destroy, and vagrant reload. That's basically the Vagrant commands you need to use Vagrant, and this commands is enough for you to use Vagrant to the expert level. And that's it, guys. Thank you for watching to the end, guys. We'll see you in the next videos where we explain more to you about virtualization, Vagrant, and other important ops skills as well.